Hey everybody, it is Wednesday, but really it's Thursday for you. I'm recording this Wednesday night. I talk about him all the time. This is the man right here. This is Isaac. You wanna say hi?
Hello. Nice to meet all you.
Did you want to tell him anything?
Not
Okay, that's cool. That's cool. See you, bud.
Are you gonna cut that?
No, I'm gonna keep going.
Okay.
All right, so what I want to do again is two different lessons. The first will be a review and then your assignment, because your assignment actually is more cladogram stuff. And then the second video will have some classification stuff in it. It is warm out today. Everything looks good. We're going to have a fire tonight, so I thought I'd record this real quick. Oh, also, I got new screencasting software that I think lets me edit stuff and put clips together. So we will see how that works right now. So it's this thing. It's called Screencast-O-Matic. If you're interested, you're not. So here we go. A quick review of cladistics, of cladograms, which is what you're going to be doing. Cladograms are just diagrams that map out evolutionary relationships using what we call derived characters, the things that once they show up, they kind of stick as you move on down the evolutionary line. A group that has the same derived character is called a clade. The diagram you learned how to make is called a cladogram. A bunch of you have already done a great job on that cladogram diagram and answering those questions. We used the example of these characteristics, these derived characters, and building a cladogram. We said that time always goes up, that everybody makes it to the top or else they're extinct, and that every derived character comes, just before the split of the first critter to have it, and they get off the bus there and they don't get any of the other ones. So amoeba got off the bus there, they don't get multicellularity, so on, so on, so on, so on. At this point, I think you know the drill, and so we can expand what you're doing a little bit. And so we're going to do that with your first assignment in that is online simulation, which is called well, I'll just show you how to get there. If you just Google, I'll put the link here too, but if you just Google Nova Labs Evolution, even if you misspell it, there it is. And it's the same place that did that RNA lab that drove us nuts because of the internet stuff. But this one I've had really good luck with. We did it last year and it was great. And so if you hit play game, remember that you have to sign in with your school Google account. And so do that. See, I've got two. I've got a personal Google account as well, but I can't use that. I'm going to use this because eventually you're going to be taking a screenshot of your progress and sending it to me. So do not miss that. So you hit play game and you get in. Now I've actually finished all of them, so you'll see something different than me. You'll see that mission 1 is open. And so mission 1, you open up. You've got a video to watch.
Let's talk tree basics.
And then you're going to start doing cladogram stuff. Now, I'm going to kind of let you figure it out. It's basically moving this stuff around. Follow the tutorial, and I think you'll do fine. But that is your assignment for what? Tomorrow is Thursday, so due Tuesday is going to be missions 1, 2, and 3. Let me just make sure that's what I want to do. Yeah, I think 1, 2, and 3 are going to be due Tuesday, and that is your homework. All right, so let's get into the new stuff for today. You've got your cladogram homework. It's now it's Thursday morning, and I'm scrambling to get this done so I can post it for you guys. So not a whole lot today. So like we said, the highest level in taxonomy is domain. Domain, kingdom, phylum, class, order, family, genus, species. So let's look at how those domains are laid out. There are 3 domains and 6 kingdoms within them. You don't have to, well, just copy the top part. You don't have to do this diagram because it's kind of a mess. But tree of life wise, you know, everything starts here with a big question mark. Domain archaea is the kind of old bacteria. We'll explain what that means later. Domain eubacteria is bacteria like you're used to, and then domain eukarya is everything else but bacteria. And those consist of, we've got, again, archaea and bacteria. Eukarya consists of protists, which are kind of the ones that you can't really classify as plants, animals, or fungi, although they're like them, they're just simpler. Plants, and then fungi, and then, of course, animals, the most familiar kingdom. So that's how it shakes out. Let's do an easier to draw diagram for you. So domains and kingdoms, this is chapter 19, section 3, the 3-domain system. And it's based on the fact that we found these weird bacteria that live in places. You remember from chemosynthesis, I think, in ecology, that we found at the bottom of the ocean hot sulfur vents, in hot pools at places like Yellowstone, and in swamps, these bacteria that are very strange, and they turn out to look a lot like bacteria that lived on the early Earth. And they, based on the DNA evidence, they are as different, or if not more different, from other bacteria as either of them is from us. So they got their own domain, and then the other bacteria group got their own domain, and everything else got its own. And so that's how it works. 3 domains, 6 kingdoms. Here's the kind of diagram that you can draw. Domains on top, regular bacteria. Archaea is old bacteria, and then eukarya and the kingdoms underneath. So, pause that and get that copied in. Again, I'll post this all at the very end like I do, so you can get ready for the test with it, but please be copying these into your notebook now. Let's just briefly talk about the bacteria. Prokaryotic, remember that means no nucleus. The first domain, Archaebacteria, crazy little things that basically, when the Earth's early conditions changed to become more friendly to us, it was less friendly to them. So they basically, ones that survived were the ones that stayed in places that look like the early Earth, places like hot sulfur vents, places like natural springs that have real hot water, because that's what the Earth was like. It was like volcanic and crazy and no oxygen, geysers and all that. So these are technically the oldest organisms on Earth, by which I mean they are the descendants of the very first life on Earth. They're unicellular. Some of them live together in what we call colonies. That's actually how we first found out that they were so old, because their mats of the way they associate together can fossilize, and so you can actually find fossils called stromatolites of these old bacteria. Prokaryotes, meaning no nucleus, they do have cell walls made of different stuff than really any other cell on Earth. They are what we call extremophiles. They live in these very harsh environments, no oxygen, heat, toxic chemicals with sulfur in them, and that's because that's what the early Earth looked like. And so the early Earth is what they were adapted to. The only ones still living today are the ones living in those conditions. There's groups of them called methanogens. Those are the ones that make methane, which is a flammable gas. Is partly what swamp gas is. And so these are the ones that live in swamps. Halophiles are ones that live in extreme salt conditions. That's what halo means. And then extremothermophiles, you can probably guess, live in super hot climates. Some of them are autotrophic, and they're the descendants of the very first autotrophs, first photosynthesizers on Earth, and chemosynthesizers. Remember, the chemosynthesizers in those hot sulfur vents are the base of their own ecosystems. I think we watched a video about that. Maybe I'll post a link to it again. But then so there's both kinds, both the photosynthesizers and the chemosynthesizers. So we'll stop there. We'll do the rest of the kingdoms next week. Not sure if we'll do a test before spring break or not. I will update you on that. Okay, so finally, the homework you have is those 3 missions. Those of you who have not yet gotten your free 5-point assignment, which is to log in and join the class that is our office hours class. That's a free 5-pointer there. There's also that take a picture of your this thing assignment. Looks like most people have done just fine taking a picture of that. I've gotten some questions about how to do it, and the short answer is the easiest way is probably to get the Drive app on your phone, to get the Classroom app on your phone, and then take the picture of the assignment and upload it that way using the app. Okay? Hope you had a good day yesterday. We sure did. And have a good day today.